Yeah, 0. Oh, no. We were watching the shows because I basically
Yeah.
oh, it can't be possible. I don't. Let me just. Oh yeah, I can't remember one because I think I factored it. Oh, that's actually.
I can come around and just take a quick look and see what you did. If you could just kind of leap through it.
One over X logarithm.
One over X is it? Oh, I'm back. Sorry, that is fire.
Logarithm.
One over X is there. It is really that.
That's negative.
You don't have
Oh, oh, the extension.
Yeah. So
And same fun. Online. That's how.
Oh, because so that we went to function actually. We will buy it and see that I just said that. 2, 3 times per day.
Yeah. Of course.
I'm willing to keep order. I'm working. For this. Oh. Try to do each page of my work.
Yeah, this one. If I should say come there. Yeah. Okay. I tried this guy's stuff. Oh, for these, I spent most of my time on them. I feel like I'm on the right track for this one. I got this one. I need to stand.
Yes, please.
And they're like all of them.
Yeah. So I said X plus X R. So it's X and Y. So X plus Y is 72 minutes.
Yes.
And then X or minus or Y minus 6 that equals that.
Yeah. Visual work.
Yeah. That you
Wait, did you do the first one on page 6?
I just want to start the X minus 4 or something.
Yeah. I did that one. Did you actually use the No, I just got. And it's right.
Okay, so thank you for the time you spent on the assignments. If you'd like to meet about any of the problems, I'm happy to meet with you. Just let me know. I'd like to come by, or just come by. I teach blocks 1, 3, 5, 7. So if you have an even block that's off, you're welcome to just come on by, or you can come by direct to study. I'm always around. So drop in or let me know, and I'll make sure to be there. Yeah, during break and for lunch, it's always the second half. No, I'm sorry, the first half that I'm good for meeting for sure. And I'll probably go for a couple questions, but I want to get through the new stuff today and then perhaps hit some common questions from the assignment or from yesterday's section. So let's get to it. Parent functions. Would you please just discuss with your neighbor what parent functions you remember? If you remember them at all?
Oh, absolutely. Yeah.
Oh, so it's.
Is that a Think so. Oh, half the row, maybe. Oh my god. Oh,
So it's the artist.
Another 15 seconds. Okay. So what's one parent function you remember? Ln of x, y equals ln of x. Could you take that whiteboard in front of you and remember what it looks like? Would you please go ahead and graph it for yourself? Y equals ln of x. Want to remember what that looks like? From your point of view, I believe it is this. With does it have an x-intercept or y-intercept? X-intercept, which is 1, 0. Y-intercept, of course, none, because it's asymptotic to that y-axis. I will be reviewing that when we get to our logarithms, of course. But wow, we start off with a bang with that y equals ln of x. What's another? Yes, Baron. Y equals x squared. Can you please show me y equals x squared? You brought your pocket parabolas to everybody? Okay, y equals x squared. Cool. What's another one? Yes. Thank you. Y equals absolute of x. Please show me that one. You're feeling bold. Bam! Or this one. Yeah, the V. Okay. Nice. That's a good one. Yes. Y equals square root of x. Can you please show me what that looks like on the whiteboard in front of you? What does that look like? Yeah, this, right? Does it have an x or y intercept? Both of them. Yeah, it's the same, right? It starts at
It's an intercept.
0, 0.
I'll show you.
Yeah, intercept is just anytime it has a point in common. Okay, nice. Thank you. Mitra, you have another one? X cubed. Could you please show me that one? Maybe whiteboard in front of you. Maybe that's the easiest one. Maybe want to do a little John Travolta. Okay. Yeah, that one. Do x cubed negative x cubed. Make it whole dance. Next, what's another one? Yes, Justin. Oh, you're giant. I'm sorry. Okay, you're okay. The danger of gestures in a math class. Yeah, Brandon, you have another one?
Y equals sine of x.
Y equals sine of x. Oh, did you remember that one? Can you show me this one? Y equals sine of x? I didn't learn it. Okay. We'll be going over that, but y equals sine of x. And of course, along with y equals sine of x, there is cosine of x, which looks like, you know it, starts up and right, the first period goes like that. And again, don't freak out if the sine and cosine are not familiar with it. We'll be reviewing it, albeit quickly. We'll be reviewing it when the time comes. Any others? Y equals x, is that a parent function? Absolutely. Show me y equals x. You better know y equals x. Okay, good. Yes. Cube root of x. Ah, can you show me this one? I see it right there, from your point of view. Does it go through the origin? Does it look like square root of x? No? Half of it, right? So square root of x looks like this. Cube root of x keeps going. Because we know the cube root of -8 is negative, it exists, but if I try to do the square root of a negative number, we're blocked. So the domain is restricted for it as square root of x. Anything else? Yes. Oh, tangent of x. Okay, do you remember what this one looks like? Has a special feature called vertical asymptotes. In between each vertical asymptote, it looks like this. Kind of like x cubed, except it's ranked. Yeah, and we have them back there right behind Baron. The lowest one is sine and cosine, tangent. Right there. Oh, there's some other ones there too. E to the x, does that sound familiar? E to the x? Show what e to the x might look like. It's related to, yeah, ln of x. Because check in with your neighbor. How are e to the x and ln of x related to one another? What's the word I'm looking for? Inverse. They're inverses of one another. And again, we'll be reviewing these things. If you're like, what's happening here? It's okay. This is review that we're going to be reviewing more. So there'll be something to grab onto later. And just looking at the board there, I see there is one that we haven't done. 1 over x. Did you study 1 over x? Y equals 1 over x at some point? First up, yeah, it's super quick. We give it that much time in algebra 2, I believe. If you know what it looks like, well, it's on the board there. You got to do the crossover. It has 2 branches, one here in the first quadrant, one here in the third quadrant. Okay. Well, today we're going to look at kind of a group of parent functions. F of x. Oh, was there another one? Did I miss any parent functions? Yeah, the top 3 aren't really parent functions up there. What's the point of parent functions? Yeah, Mitra?
It's easy to graph that liquid transformation.
Right.
So you know what it's like originally, and then just like based on the numbers in front that you plug in.
Perfect. You know, shift it or flip it or stretch it or push it or something like that, right? Does that sound familiar? Again, we'll review them in a little bit more detail a little bit later. So we're going to look at the function f of x equals x to the n, and you may be asking yourself, what is n? Well, here it tells you. Will you just check in with your neighbor to see if they have any idea what's in the parentheses there?
Yeah, I do.
R was a double.
Yeah, that's what I was.
I think it's.
Or is that not rational? Never mind. So that's also.
It's just like, oh.
This symbol here is element or an element of. Yeah, what is Z? Is it integer? I think there's maybe some process of elimination. Is it real numbers? Is it all real numbers? It's not all real numbers. That would be an R with the double staff R. Is it something else it could be? Whole numbers.
We know, but that's only positive.
That's only positive. And that would be W.
W.
Yeah, whole numbers would be a positive. A W. The first whole number, would you please show me what the first whole number is? As opposed to the first natural number. Whole numbers and natural numbers are different. Exactly. Whole numbers, those are the ones that look like a whole. So that's the only difference. Natural numbers start with a 1. Natural numbers also known as counting numbers. So Z, oh, and natural numbers, simple for that is N. So this is, as you said, integers. Integers begin with, yeah, there's no beginning at negative infinity. It's just -3, -2, -1, 0, 1, 2, 3, etc. So let's take a look at some different cases because, so I'm saying like here we're looking at x to the first, x to the second, x to the third, x to the fourth. I think we already talked about 3 of those already, didn't we?
Yeah.
Maybe 4 of them. So let's kind of group them into different categories. If n is greater than 0 and it is even, does it make sense that the function is going to look like this going up here? And on the left side?
If it's like to the fourth, there's like some wiggle.
Yeah, what would the difference like between x squared and x to the fourth be? Thinner, right? It'd be thinner. The reason this goes up so quickly, like we're talking about x squared, it goes up quickly because you're squaring the numbers. It goes up on the left side because when you square a negative number, it goes up. It's still positive. And if we're doing x to the fourth, it goes up quicker, doesn't it? Except right here, like if you have a 1, just some nuances that I don't care about, but you may find interesting. If this is, and these all go through 1, 1, -1, 1. There's some differences here, like square 1/2, think about what you get. If you take 1/2 and raise to the 4th power, you get 1/2 to the 4th power. Do you know what that is? 1/16, isn't it? Yeah. 1/16. So this actually becomes flatter here. Well, these become steeper as that number gets bigger, like x to the 6th, x to the 8th. These are getting steeper, but it becomes like most flat at the bottom as that number goes up. But all I care about is that it looks like this. I don't care about right now the nuances of the curve. I just care about it goes up in both directions. So that's the first one. The second case, of course, if n is greater than 0 and it is odd. Do we know what that looks like? Yeah, it goes up pretty fast here, just like squares into the 4th. And then on the other side, when you plug in a negative number, down. So the other 2 cases?
It's less than 0 and even.
Yeah, that's an n. N is less than 0 and even. Well, for instance, like x to the -2, x to the -4. I'll give you a moment to think about what this looks like. Y equals x to the -2nd. It's going to look. I'll give you a moment to discuss with your neighbor. What would this look like? Do you have any idea? Let's do specifically x to the -2nd.
The root of a negative.
Okay. So first of all, let's rewrite that x in negative second. Don't you think that's a little bit uncomfortable? Yeah, y equals 1 over x squared. Correct? And of course, x in negative fourth would be 1 over x to the fourth power. So what does this thing look like? Have you studied this at all? It has a 1, 1, just like the other ones. I think, does it make sense that all the outputs are going to be positive here? No matter what, the outputs will be positive. So I'm going to move that x-axis down because I'm not going to have any negative outputs. So I like that. Thank you for that. 1, 1, I'll go through that. And how about negative 1, comma 1? Okay, I'll go through those points. But aside from that, nice. Whoa. Yeah, danger in the math class. Does it make sense that it would look something like this? As you plug in larger and larger numbers, the value is going to get closer to 0, isn't it? And I put half, I have a convention of putting half arrows in it anytime I'm approaching an asymptote. It's not standard. I don't think any of the other teachers here do it or anywhere else, but I really like indicator that's going towards an asymptote with that half arrow. You can use it or not. And in between the 0 and 1, I hope it makes sense. If you plug in a 1/2 in the bottom, 1 over 1/2 squared is actually equal to just 1 over 1/2 squared.
4. It's 4.
It's 4, isn't it? So at 1/2, it goes up to 4. When you plug in a 10, it's up at 100, isn't it? Can you go through those mental calculations? So from 1/2, it went up to 4, and then 1/10, it went up to 100. Imagine 1/1000 million. Right, it's going up pretty fast. And then when you plug in the negative number, I hope it makes sense that it's going to be the same, isn't it? Get the exact same output. So it has symmetry about the y-axis. What kind of function is that called if it's symmetric with respect to the y-axis? Can you check in with your neighbor, see if they remember? What kind of function is that called?
Oh God.
What's the word I'm looking for?
Even.
It's an even function. If it's symmetric with respect to the y-axis, it's an even function, which it's actually even listed here, isn't it? Interesting. Okay, odd. Looks just the same in the first quadrant. And what did I hear about reflection? Yeah, what kind of symmetry is this called? It's an odd function and symmetric with respect to the origin. Okay, so they're all gonna look like that. If it's there's a typo there, isn't there? Less than 0, thank you. I regularly make careless errors. I'm sorry, it's never intentional. So if there's something there that doesn't match what I'm saying, please let me know so that no one else is copying down wrong stuff. Having n is greater than 0, that was bad. Shame on me. Human. Okay, so this begs the question, end behavior. Have you studied end behavior? Your end behavior in general is just talking about what's happening to Y as X approaches negative infinity or positive infinity. What's happening to Y as X approaches negative infinity or positive infinity? There are only two ends to any function, the left and the right side. Now, some of them don't go all the way to negative infinity, right? Like we talked about ln of X. I'm glad you asked. Yeah, we'll be talking about that today. So thank you for the motivation to get there. Limit notation. Have you used limit notation in a class before? Okay, some yeses, some nos. I think this is where we start to diverge in what we've learned. Maybe you've learned something like, I'm going to talk about this one, just a nice parabola. Maybe you've done this as X approaches infinity, Y approaches infinity. Does that look familiar? Or is that comfortable for you? Okay. Been a while? Okay. And also for the other end, of course, we would say as X approaches negative infinity, Y approaches
Infinity.
infinity. And we can see it visually, can't we? As X approaches negative infinity, Y approaches positive infinity. It's just asking what's happening to the Y's as we control the X. So that is an intuitive sentence for end behavior. Yes. Hello.
Figure out and then you say if it was the approach.
Yeah, pretty much that's it. We look at the degree and then I classify it. Is it going up, up, down, down, mixed, etc. There's a more formal way to talk about this end behavior using what's called limit notation. So I'm going to rewrite these in limit notation. So it starts with a lim. Is it looking familiar? No? No? Okay. I have a little subscript underneath it. Right now it says limit as X approaches infinity of f of X equals infinity. So the first two lines say the exact same thing. This would be read the limit as X approaches infinity of f of X is equal to infinity. Or you can say the limit of f of X as X approaches infinity is infinity. As grammar goes, you can kind of shift phrases around like that. I learned that in English class. Or maybe just living.
The arrows last year, they just placeholder.
Yeah, or replacement. And the arrow we have now, and this should be the only arrow you use in notation, is this X approaches, and then this is a double arrow. Not double, it's a normal arrow. It's not like one of my kooky asymptotic arrows. So could you already write the next sentence in limit using limit notation? I'm pretty sure you can. Straightforward. The limit as X approaches negative infinity of f of X is equal to infinidad. Yeah. Okay, so end behavior. A, is there a parent function for A? We could probably manufacture it, but we're not going to. End behavior of this function is the same as just y equals, I'll say 3x squared. I want to keep that leading coefficient. And then we could use our parent functions to go from our x squared to, could you show me what would happen from x squared if this is our parent function, what, to 3x squared? X squared changes to 3x squared, right? It's stretched, vertical stretch by a factor of 3. Or we could think about that as a horizontal compression by a factor of 1/3, I guess. It's more naturally a vertical stretch by a factor of 3. So the end behavior using limit notation. I think we already did it, didn't we?
Yeah.
Limit as x approaches infinity of f of x. And maybe since there's no f of x, we could write a y here is equal to infinity. I'm just going to change it up to show you that there are different things we could do here.
You do negative.
Oh, I definitely do. Yes. We could do this. I think I did these correctly now.
Do you have a preference?
I just want it right. Yeah, anyway, it's fine. It seems to me that since there's no f of x here, rather than do f of x, it makes sense to put y there. But f of x would have been perfectly fine because it's definitely a function of x. Or just to stick the whole function in there is fine as well. Just options. Would you please try B and D? Just B and D. Once you finish with each one, or if you're stuck, check with your neighbor. Interesting twist in D.
How do you know when you write like f of x or between times what?
Basically, you're referring to the functions.
Oh, so.
Yes.
It's like zero, it's back. Oh, wait, x cubed? Oh, it's like. It's back. Oh. It is less than zero. Yeah.
So now.
Just remember, it's figuring out what's happening to y as x is super.
Yeah.
Oh, you like this. It's now, yeah, we're back. Then. Yes, next. Yeah.
Is that ready? Okay, let's go over it. D. So limit as x goes to infinity. So let's have everyone come back together.
I don't know.
Let's have everyone come back together. Limit as x goes to infinity of y is equal to
Negative.
negative infinity. Are we comfortable with that?
Yeah.
And the other one, limit as x goes to negative infinity of y is equal to infinity.
Yeah.
And we know this because end behavior is the same as in our mind, we're doing y equals negative x cubed, and we know that that looks like this. The only difference is there's going to be some squiggles and it's going to move up and down a little bit. Up or down, or left, right. Okay, D. Limit as x goes to infinity. And I'll put in a 3 to the x here because it's nice and short. As x goes to infinity, that limit is infinity. But the other one is 0. Yes, it is equal to 0. Right, in our mind, we're thinking about this graph. We know that it goes up to infinity here, and on the other side, once you're familiar with it, what's happened with those y values? They're approaching 0. Now, if you don't know the graph, you could plug in huge negative numbers like negative 3. 3 to the negative third power is 127, which is already pretty small, isn't it? At just negative 3. 3 to the negative 10? It's almost nothing. I have no idea what that is. It went over a huge number. Do you agree? Went over a huge number. It's basically 0. And we're not even, that's just a negative 10. We're saying as x goes to negative infinity, it's getting closer and closer to 0. What's happened to those y values? It's not going to negative infinity for sure. It's never going to be any negative number, but it's going to be super close to 0. How close? Infinitely close. Yeah. Okay, so you'll be able to do the other ones a little bit later. I'm going to take a moment to say we'll resume at 8:43. So now's a nice time to zone out, stretch, or ask questions about what we've done. No phones. It's here. Were you guys able to use your phones last year during break?
Yeah.
Oh, that's right. 10th grade. Did. What happens in those 3 minutes during break if someone uses a phone? What do they check? Yeah. Snapchat.
And then like.
Instagram? Kids use Instagram?
Yeah. So.
Instagram, you need more time.
So like if you. That's true.
Well, I feel like.
See what's happening. Me too.
Yeah.
No Snapchat.
So much.
Instagram.
I just give up. But I still got either. I'm like, and then like. It's always. Yeah. I'm super delighted. It's like, how about writing? I'll just write. Like, it'll snap you like this. No. I've been sure. Yeah, I really like, I was like, I have a little, and I'm like. And then she like, okay, I was like, it's just not really funny. That's casual. Like, it's just not message. I was just like, because he did. So you really did. And then I was pretty sure that actually her movie inspired by the 30. Well, I mean, I was surprised. Thank you. The last
Okay, thanks for being back from break on time. We just talked about x approaching positive infinity and negative infinity. I think that's pretty intuitive, isn't it? To just like imagine a number line and just like, walk down the line for positive infinity, walk the other way for negative infinity.
Yeah.
But how about if x is approaching like 4? Would that make any sense for x to approach 4? We might have this number line here. What would it mean for x to approach 4?
There's a transformation that moves the x-axis up like.
Interesting idea, moving the x-axis up, but it's fixed. And again, x approaching infinity makes perfect sense. It's like, I'm going this way. X approaching negative infinity, I'm going this way.
Inequality.
It's kind of related to inequalities. Ella, you have an idea? It could happen with domain restrictions or not.
Isn't it like when a fraction has like equal power on top and bottom?
That's interesting. Oh, man, some deep rational function right there. Not what quite what I'm talking about. I'm just talking about like in right here, what's going to happen if x is approaching 4? It goes towards 4. And I hope it makes sense that there are 2 ways to do that. Either from the left or from the right. So I'm going to fill in and you don't have to write this down, just kind of keep it in mind. If I'm talking about x approaching 4 from the left, I'm talking about numbers like 1, but approaching 4, I could get even closer, right?
3.5.
3.5. Can we get closer? 3.9. Can we get even closer? 3.99. But that's as close as we could get, isn't it? No, we can get much closer, can't we? In fact, 3.99 is kind of far. And I could zoom in, and this might be my 3.99, isn't it? Isn't that possible? That much space could be in between 3.99 and 4?
Not with the 5, yeah.
Yeah, not with the 5, but not that I could erase that. So I could get even closer to 4? Like how much closer? 3.9999999. Would be pretty close.
3.9 repeated. You're just infinitely far.
It's infinitely far. Oh,
And
infinitely close. Okay, so that's approaching 4 from the left. But we could also approach 4
Right.
from the right. Numbers like 5.
or
4. Okay, you guys just went for it now.
Oh, yeah.
At 4.00001. Could we get even closer than 0.00001?
you could.
Keep putting those.
Can you put like O bar and then the 1?
That's not allowed.
That's definitely violated some sort of mathematical idea.
So the bar was 9.
That begs the question. 3.9 bar.
Yep.
Is that less than 4?
Yeah.
Is it?
Yeah.
You haven't discussed this? Oh, what's that? Yeah, 0.9 bar. Is that equal to 1?
What is it actually?
No.
Is it?
No, it can't be.
It's super close.
It can't be equal.
It can't be?
No, it can't. It is.
You're like half around just because you can't actually have
Well, no, you
in
can't.
functional usage, like it's very difficult to have an infinite number, so you have to round.
Oh, do we have to round?
No, that's why the bars.
No, 0. 3 bar is the same thing as 1/3, isn't it? You see where I'm going, don't you?
Can't write it as a fraction.
0.3 bar is 1/3, 0.3 bar is 1/3. Is this true? Why am I writing this 3 times? About to add them. On the left, I think this is gonna add up to exactly 0.9 bar, isn't it? And on the right, it's not approximately.
No, but
It doesn't feel good,
no,
does it?
That doesn't.
those aren't the same number.
No? Okay, here we go. 0.1 bar. Do you know what this is equal to?
1/9.
If you were to write this out, if you were to do some division, it's equal to.
But that's not the point.
One.
Those are different numbers.
Are they?
Yeah,
Wait,
there's a one
this
in
is
one of
different
them
number?
and a 0.9 in the other one. Those are different numbers.
But I guess they have the same.
Imagine that the 0.3 repeated forever, 0.3 repeated forever, 0.3 repeated forever, when that results in 0.9 repeated.
Yes.
Forever. Sorry, so where is the inequality here?
There's the inequalities in the numbers that you wrote that are equal to each other.
I know,
It's not the same number.
do you know 0.2 bar is equal to? Oh, I'm sorry, I'm doing this wrong. I'm doing this wrong. I'm doing this wrong. This is dumb. I did this wrong. 1/9 is equal to 0.1 bar. 2/9 is equal to 0.2 bar. You know, the 3/9 is equal to 0.3 bar, I believe. You see where I'm going with this?
It's still wrong. There's different numbers.
9/9 is equal to,
Right, so then why is there an equal sign?
because they're equal.
Exactly.
Which one is not exactly equal? No? You need a different one?
Two different numbers are the same number.
Okay, 5 divided by 5 is equal to. Okay, I'm gonna verify this. You ready?
I'm not gonna verify it, it's wrong.
I'm gonna verify it. It's equal to 1, isn't it?
Not.
5 goes into 5 exactly 9 times.
Sorry, what? Oh, 50.
I'm kind of forcing it. 5 goes into 50 9 times. As long as I keep doing this.
Or different number.
And 5 goes to 5.9 bars. Goes in 1 time. I don't like that one. I like this. This first one, I think, really just seals the deal right there. It's just, there's no denying
It'd
it.
be great if it was right. It's just not.
So is there a number that's, looking at, is there a number that's directly before 4? Is there like a penultimate number before we get to 4?
Like.
I mean, it's 3.91.
Yes, but like no.
8 repeating.
3.8 repeating, but how about that 9 after the 8? I think
I don't.
there's no number. There's no greatest number. There's just no greatest number because, like, no matter what we say, we could zoom in. If I have 999 here, I could still zoom in.
Right, and so you put a bar and then you're there.
But this is 3.9 bar.
So it's not. It's not that.
Wait, would it be that like 1/3 is kind of like a rounded, like not rounded number, but like 3.3 repeating, it like stops at some point.
I don't know. Let's see.
So.
Let me do the same thing here. 3 goes in
We're not gonna.
3.
This is propaganda.
Is this going to stop at some point? Should I just keep see what happens? Maybe I'm just going to spend a few years and see if this stops. Come back in 2027, guys. You're dismissed. I'm just kidding. It never ends. 1/3 is 0.3 bar. Forever.
Right.
Just if you don't stop, it's equivalent. If you stop, it's going to be a problem. If you don't stop, it is equivalent, hence the bar. In any case, I feel like I've gone on a tangent here, but that 0.9 bar, same thing as an integer. And it's uncomfortable. I know. Look it up on YouTube. You only find the truth on YouTube. Or not. Okay, let's get back. Oh, I was running on the same sheets. Okay. So here. I hope that this makes sense right here. The limit as x approaches a, so negative is not negative a, it's from the left. Approaching a from the left.
So A with the negative, like higher means from the negative side.
Just negative is on the right side.
Okay.
And it's a subscript as well. It just means it's coming from the left. So like, I don't know the number. So I can't even say 0.9 something, but if this is a 5, we'd be like 4.9, 4.9, not 4.9 bar, because that would be 5. But as x approaches a from the left, do you see what the limit is?
Yeah.
Because it's asking where the y values are going. So according to this graph, that limit is L, isn't it? Yeah. Maybe ask yourself, what the L? It's just L. Whatever that is. Now, is it exactly L? We just see that it's going to L. And this one is.
Wait, so it isn't L?
It is an L.
0.94 L.
What?
Wait, give up.
No, the limit is L. It's just saying it's going to L. Does it reach it?
No, because.
In this case, it does, because that's a solid. Well, it's in the past. We're just approaching, we're just looking, we're magnifying. it. On the other side, oh, it just.
What would like be like if they use for why would want to follow it?
Good question.
Like that.
This is the foundation of calculus, the study of functions. And sometimes we know what it looks like, sometimes we don't, so this is a tool. And this is really vanilla. This is like, oh, we're looking at it, so kind of obvious to see that where it's going. This is just practice of what's happening. In this case, and I hope it's obvious, limit it as x approaches a from the right. Right, I mean, we're approaching here. We're just saying, oh, look, it's a little bit higher than L. Oh, it's a little bit closer than L. Where is it going? It's going to L.
Okay. That's fine.
That's all I'm saying.
So the positive like means you're approaching it from the right.
From the right. It's called the right-sided limit of left-side limit. Infinity doesn't have a right side or left side because you can't get on the other side. Right, if you're talking about positive infinity, just x is going to positive infinity, x is going to negative infinity. But if x is going to any integer, it can be from the left, from the right. And that's what it looks like. Oh, look at this interesting function here. Is it a function even?
Yeah.
Yeah.
How do you know it's a function?
Vertical line.
Passes that vertical line test. You remember the vertical line test? You sweep a vertical line. It fails if it ever hits more than one place. Okay, so that first one, let's see if you could do 1 through 4 with your neighbor.
0. Oh.
Well, wait a minute. How do we do?
What? Just number 1. Did you get number 1? Did you get the answer? Show me the answer if you didn't have any idea what it is. Visually speaking, we could see that it's 3. I'm looking, let me zoom in a little bit here. So I'm plugging in points very close to 0 from the left. Okay. Okay, so that y value is like 3.1. I'm getting closer to 0 though. 3.08. I don't know. But I can see that they're kind of settling on the 3. That's where these y values are going. Yeah, Barry?
Wait, so it's always going to be the same when you're approaching it from the positive and the negative side, right?
Good question.
Because it's the same.
We'll be
Oh, I see.
exploring because there are different nuances you can use this graph as a
Yeah, look at my.
Yes.
Sorry, just like explain it one more time. Yeah, I understand.
Sure. The question is asking what's happening to the y value since x is approaching 0 from the left. So I look over here and I say, oh, it's like 3.5, but I want to get closer to 0. So like here, I like to say, oh, it's it's less, it's 3.2 or something. It's closer and closer. I can see that those
So it's
y
going
values,
towards 3.
the y values are going
Okay.
towards 3. And that's what it's asking. What's happening with the y values as x is approaching
The
0
limit of.
from the left?
So they just.
Should not work.
Well, did you?
Well, the negative says two.
Can you finish up through 4? Yeah, Justin.
Yeah, like how the versus how you use it two minus versus two plus versus just plain two.
Oh, I think there might be an error there.
Yeah, there's a minus.
Oh, I see. I see. Like this compared to these two. Thank you. I didn't talk about that.
But those are different.
Or is it, no,
Okay.
you're right, you're right, it's negative because it stops.
Let's talk about 1 through 4.
Just one.
The answer for 1, of course, like we said, is 3. The answer for 2 is 3. When it says x is approaching 0, the implication is from the left and the right.
Okay.
If they match, then we just say that the limit is 3.
What if they don't
If they don't, then we would say that the limit
define?
does not exist. It happened. The limit does not exist.
That's so much cheese.
Do you know what f of 0 is?
Yeah,
It is 3. Are all these the same questions?
yeah.
No, but.
No, they're different questions.
They're different, they might get, but they're the same.
This one, we only care about what's happening at that point. We go to x equals 0 and just go up and say, okay, I'm here at 3, done. The other ones are saying, where does it go? Where does it go? It's going to slightly different. 5, 6, 7, 8.
But it's approaching there. Yeah.
Let's see what's happening there.
I have negative one.
I said.
Yeah.
Yeah.
Oh, no, I meant like.
So what does it even say right here?
As x is from the left, as it's approaching -2.
From the left.
It's an open on there.
Yes, x is approaching -2 from the left. So is there an answer for that?
Oh, no.
It is negative.
-1, isn't it?
Wait, isn't it both? It's not.
So on the left side, we're
Yeah,
looking here.
it's approaching, it never gets there.
Yeah, and perhaps you recognize, and this is peculiar, is, I feel like that border is too thin, don't you think? Yeah, it's too thin, but it's definitely an open circle, and the implication is that it would hit that point, but there's nothing there. It's the, what's that called? That place, the cusp,
Wait,
the -1 is going to -1. Yeah, me too.
what about like the point on the top, like at 1? Wait.
Yeah, is it going to that one? The Y's are not headed that direction when we're looking from the left. From the right,
Yes.
those Y values are also, they're headed down.
It's -1, -1.
So are we
They
just
match, so it's again -1 and then 1.
And then f of -2 is 1.
That's
That is a difference there. So they were going there, but
they did it?
the function says, surprise, there's actually nothing there. This function is picks us up at 1. So they're going to the same place, weren't they? They're going down to -1.
What is it a function of?
Oh, this is just random.
Oh,
They're completely random. Some mathematician read this.
okay.
We're gonna try 9 through 12.
Right, no, we got it. It's in the 13. Yeah. Maybe from the side, from the side, it's going to 1. Make this a little bit too.
Two or is it?
Third question.
It's called the law. No, that's, yeah, I think.
Okay. Negative one.
When you went.
If there's no, is it undefined? Is it?
Something intelligent. Yeah, I think that answer was perfect. Yeah, just don't make up like a value.
Sure.
Did you get them? For number 9. Show me what you got.
For 9.
Number 9, show me what you got.
Two.
2. Number 10, show me what you got.
1.
Is that clear that it's 1?
Yeah.
From that right side, it's just follow squiggly. Where are the Y's going? Does it ever actually get to 2?
No.
Not as X approaches 2 from the right.
Wait. Right.
Oh, I'm sorry.
1.
I'm sorry, 1. It definitely never approaches, it never gets to 2 from the right. For number 11,
No, it doesn't.
Does not exist.
does not exist. We do D and E. I'll put in here just to help you out. Left and right side don't match. Where have you heard that does not exist? Limit does not exist before? How many of you have seen the movie Mean Girls? Do they have it in the new version too? Did you see the new version?
Yeah.
What's that? Oh, the musical. Did they have at least limit does not exist in the musical? Oh, that's a worse offense than making a musical. Oh, and F of 2?
1.
It's just 1. So these are some nuances that we'll be looking at together a little bit later. I'll let you do these on your own. I think that's all the new stuff I have for you. I do want to go over maybe some of the questions from the assignment, not from the last section. So what would be a good one to go over? You try this one?
Oh, you had a review.
Oh, I was confused.
This will be a good one to review, I think. Page 8, example 5. I'll go over this problem in about 2 minutes.
Sure. Actually, you're right. So they're never gonna match those. For 16, they just.
Put everything over. Bro, I know. Bro, I did all my operations. Now, this is what I was doing.
Well, no, and even though if they're consecutive, you could also just say X is one's X and one's X two. Right? Oh my god. It's so stupid. So X, so you can do X it's Y. Wow. And then I just Y. Thanks, I'm sorry. But it's one. Yeah. And then but Y, I want to. That's like, if you guys have to eventually, that's.
Oh, good luck.
Okay, you just first. Okay.
Sure.
So it's. So it's like crazy numbers. Okay. Thank you. Right? That was easy. Yeah. You get 100 points too.
If I see that on a test,
I know.
I do the same.
Could you run two and you can't test it?
And you figure out, yeah, you can't. So you could, you can't.
You know, I
It was the other 11 X was fun. It's like, I can't be much. And then.
We want to add like.
Oh, you're right. Oh, yeah. I honestly. You must be like, yeah, I was. Make sure that it's two, take that, right? And then you can bring that all to one side. But I just go with it. That one is just one. But mine is. Oh, yeah. It's just one like. Because it's 2x here. And I'm. 5x. Oh, like,
Yeah.
2x, so it's
Big
negative
DX.
one. I'm making it. Well, I can try to upside it.
Okay, folks, can we do this? No,
I.
you got it? Okay, so let's come back together.
You can't.
Yeah, it's one.
Oh, I guess.
Let's come back together. Everybody, let's come back together. So as it's a word problem, I think first order of business is to do what?
Define your variable.
Define our variables with the let statement. So let the first integer equal x. So second integer x what? X plus 2. Oh, it's a even integers. Yeah, gotta be x plus 2, huh? Okay, so now what? Reciprocal. The reciprocal of x is 1 over x. The reciprocal of x plus 2 is 1 over x plus 2. And we know that these sum together to be 11/60th. And what should I do to solve this problem? Yeah, let's cancel all the denominators. And multiply it through by x plus 2, and 60. So 60x times x plus 2. On the left side, don't forget to use the distributive property. X is canceled, leaving 60x plus 120. Did I do that right?
Yeah.
I'm okay skipping a little bit. I just canceled the x's there. I'm not going to cancel it from what I've written, though, of course, because I still need to distribute. Plus 60x equals 11x plus 2. And if you want to multiply that out, you may. I'm a little bit of skipping that step. Did I do it right so far?
Yeah.
What kind of equation are we dealing with? How do you recognize this quadratic?
Because you got an x times another x.
We have x squared in there. Could you just review with your neighbor what are the different methods you know to solve quadratic equations?
That's actually.
Here, let's start with the favorite. What should be your favorite factoring? I hope that's your favorite.
I'm gonna go out on something to say this doesn't.
It's just the same equation.
Well, if it's integers, I hope it factors.
But there's an 11 on the other side.
Oh, we'll see. So there's factoring. There's also, what's another method? Quadratic formula. Do you like quadratic formula?
It's okay, it's just a little long.
Yeah. And is there another way?
If there's two.
Ooh, completing the square. Does that bring back happy memories? Square? No? That's one you love most, is that what you said? Nice. Oh, they're doing it right. Like it. That's my second favorite. Because of course, if it factors, just factor it. Why beat around the bush? Factor it, complete the square or quadratic formula. Yeah, I'm seeing that we have a 120x plus 120, and I'm seeing 11x squared plus 22x. I do that right? Can I divide through by anything to bring this down a little bit? No. Oh, that's painful. So I'm gonna move everything to the left, to the right, and then make that the left. So 11x squared, minus 98x, is that right? Minus 120 equals 0. Did I do that right?
Yeah, no, that's right.
Now, this definitely factors, but I can't imagine a more obnoxious.
Well, that's right, that's plus.
You got 11x plus 12 and 11x and x minus 10.
So how did you do that?
No. I'm not sure that works, does it? Okay. I see. So just trying stuff you got.
No, it doesn't.
Yeah, there's not a whole lot of different ways to factor 11x squared. So I think 11x and x. You just play with it until you found something that works for that main term. I see you have 1 times x minus plus 12x. Get that negative 98. So we see the integer one we're looking for is x equals 10.
And then.
Yeah, we don't need that other one. It's not going to result in an integer.
Okay, so the answer is for 10
10
and
and
12.
12.
Yeah, 10 as well.
Sure.
There we go. Should we check it?
I think.
It resulted in a pretty number and it seems right.
I think it is A or K.
Folks, you finished your first week of pre-calc, advanced pre-calc. Nicely done. Have a great weekend. I'll see you on Wednesday. We have our quiz on Friday. Is that right? Oh, just can you finish the whatever we didn't do? Yeah.
When does the online one work?
Probably after this. I don't know if we'll see. It's coming. Yeah, make sure you're able to get online on my math lab.
It's cool.
Thank you.
My pleasure. Have a great weekend, everybody.